This is the last and final episode in the Hibernate series. In this episode, shall take a look at working coding examples, working with collections with related objects, and how to lazy load and cascade operations work from the coding perspective.
So let's go to an example. So you see here I have a customer. I start with customer just like before, and I'm going to loop through and I'm going to add 5 orders. And so I have a little Fluent interface here for I set the customer on the order, which I don't actually have to do. That's just for completeness. I set the amount to 100 plus, whatever the iterator. I set a bunch of values. Let's just do that. And then finally, I add the order to the customer. I save it, and what you'll see is I'm just saving the customer. Notice it's going to actually do an insert on the customer and then 5 inserts for the order. Finally, I'm going to load it back up. I'm going to print out the customer. It will not have loaded the orders at this point. As soon as I call this for each and it hits the get enumerator method, boom, that's going to trigger lazy load. It's going to grab all 5 orders. Finally, I'm going to delete the customer. And since we have all delete orphan, this should also kick off 5 delete statements to delete the it's going to issue 1 delete statement, basically where the customer ID equals the customer I just deleted. So I believe we're still running here. Yep. So I'm actually going to fire up 3. And you'll notice here it inserts the customer, it inserts the 5 orders. We're going to load the customer back up. Notice it's not loading any orders yet until we hit the for each. And you notice it just issues 1 select statement where the customer ID equals the customer ID we're dealing with. And then here we just loop through and print out each one. You see it's 100, 101, 102, 103, 104. Finally, we're going to delete the customer, and you notice it has it all in memory. It knows everything it needs to do. It doesn't need to go hit the database again to figure out what to delete. It just deletes the 5 orders. It needs to do that first, just in case there's a foreign key constraint, because it'll blow up if you try to delete the customer first. And then finally it deletes the customer. So one of the other things I want to talk about is object lifecycle. I've talked about save and update and delete and cascade and stuff like that. And Hibernate does actually have a predictable lifecycle model. You can tell it, you can tell it when you want to do things. You can set up ahead of time how it's going to behave in certain situations. So I've showed you when associated objects are saved and it's set to cascade all or cascade save update, it will go save any related transient objects, where transient means it has no ID, it hasn't been saved yet to the database. So we could have done save customer, save store, and it would have worked just fine, and then flush. But we didn't need to since we set up cascade save update. When associated objects are deleted, they're deleted when you explicitly call delete on them, or they've been mapped with the cascade all or cascade all delete orphan or delete. So NHibernate will not just go start deleting stuff for you. And if you don't tell NHibernate how to do that correctly, you can get your database into a screwy state. So it's generally recommended either you handle that yourself, like you go issue a query and get all the orders and then delete them yourself, or you set up the cascading strategy for NHibernate and let it do it. Oh yeah, that's right. I knew there was something. In order for all delete orphan to work right, it requires the inverse equals true. That's right. I actually ran into that. So in order for it to figure it out, if you don't have that, it won't necessarily. I have to brush up on the documentation a little bit on there. It gets kind of tricky, but basically the docs say, if you're going to do this, you need to do this also. You need to tell it what the other side of it is. The recommendations for when to use cascading, this is actually right out of the NHibernate documentation. Use cascade all for true parent-child relationships, or all delete orphan with the inverse equals true. If you, for whatever reason, can't use all, then you should at least use save and update, and you can manage deletes explicitly yourself. Lifecycle objects are ones that are set up for cascade all, and this is kind of some jargon that the NHibernate docs use. They'll occasionally reference lifecycle objects, and this is the kind of concept where I can just kind of deal with the one object I care about, and any related objects or lists of things are all managed through the configuration through cascading, so that I can just deal with the one object. I can just save that one object, and then NHibernate will figure out what all the other objects in the graph that need to be saved. This works really well in a domain-driven design scenario if you practice domain-driven design, and where you're only supposed to deal with the aggregate root object. You're not supposed to muck around with the children root. I don't want to get into domain-driven design, so please don't ask me any questions about that right now. But this is the type of scenario that's envisioned, by dealing with aggregate roots. Finally, I'd like to go into querying. So you may be wondering, like, well, how do I list all the customers where their highest order is over $5,000 or something like that? So there's actually two major ways of querying within Hibernate. There's HQL, which is Hibernate Query Language, which is very SQL-like, but you don't actually reference explicit column names, and there's some extra functions that are like statements, I should say, operators, if you will, in HQL that don't exist in natural SQL, and HQL will translate those statements into something clever in the SQL. And then finally, ICriteria, which is actually like a fluent interface for building up a query in an object-oriented sort of fashion. So we'll get to that next. So let's look at our example here. So here we're going to create a store. And I have a method here which actually has all the speakers from Houston Tech Fest. So it's going to create a whole bunch of customers, and it's going to loop through each one, and it's going to insert them in the database. And just to make things interesting, every fifth one, I'm going to assign a store to it. So all the others aren't going to have anything. So I can't remember how many total customers. It ends up being about 13 No, I think it was 8 or whatever that had they have a store attached to it. You notice here I'm just saving the customer, and it's gonna save the store if necessary. And since I'm in the middle of a session, see, it's the same store. It's only going to save that store once, or attempt to do an insert once. It's going to realize, hey, okay, I've already flagged store for insertion. I'm not going to issue a bunch of insert statements. And then finally, I'll call flush here. It should issue all those select statements in insert statements in one big batch to save a bunch of round trips, maximize performance. And so that'll get us all our customers. Now for HQL queries, I can do all sorts of SQL-y type stuff. First, give me all the customers where the last name is like, or starts with M, basically. Do a count query. You can do aggregates, projections. So basically select the count of customers where the last name starts with M. Finally, I could say select the count of customers where its related store's name starts with Bozos R Us, or just Bozos. And then finally, for ICriteria, I've basically done the same thing here. So you can look at the source code later. I'll make this available. But this is, let's see if we can do a split view here. I don't know if you guys can see this. So here, from customer C, where last name like last name, this does the exact same thing. Here we're doing a count from customer where the last name it starts with M. So you have match mode start. And then finally select the count where the store name. So we're saying you create criteria for customer. Set a projection. We're gonna do a count on customer ID. You have to give it some column. You can't just say star, I guess. We're going to create an alias, basically a join to store, where the store.name starts with Bozos, and then we're going to return the count. Let's go ahead and we're still running. Okay, so I'm going to, that's 4. So here it's inserting all those customers, and then it's going to use HQL. It's going to select all the customers that start with M, there's 4 of them. It's going to count all the customers that start with M, 4. And then it's going to select all the customers that basically had that store Boses R Us assigned to it, and it turns out there's 13 of them. And then the same thing with ICriteria, it's 4, 4, and 13, and it issued almost identical SQL.